Hello, friends. How are you? I hope you are doing really good. Nowadays, we are learning about center of gravity. And in the today's video, we are learning about center of gravity of lamina. So, see what I have. So, what is lamina? It is like a planar sheet which has length and breadth, but thickness is negligible and mass is uniform. So, for mathematical calculations, we take area for calculating its center of gravity. Engineering Fundamentals by Yugandhara Tayale. Content of this topic are like this. We will see examples on center of gravity. Examples on center of gravity of lamina. So, to calculate CG of the lamina, we will follow certain steps. So, it will simplify the calculations. First, we will decide the reference system, that is x and y axis. Then we will divide given figure into basic components, that is basic geometrical shapes, example rectangle, triangle, circle, etc. Then we will make calculations according to this table. We will calculate area of those basic components, then x coordinate of CG of that basic component. Then y means y coordinate of CG of that basic component. Then we will take product of a into x and product of a into y. After doing the calculations for all the basic components, we will take summation of area, summation of a into x and summation of a into y. Then we already know for x bar for lamina is equal to summation of a into x divided by summation of area, and y bar is equal to summation of a into y divided by summation of area. For solving the problems, we first need to know the CG and area of basic geometric shapes. So, for rectangle, its B is breadth and H is height. So, you already know area is B into H. Then C1 is B by 2 and C2 is also B by 2. For triangle of base B and height H, area is 1/2 into base into height, and C1, that is, you will understand it like this. From the perpendicular side, C1 is equal to B by 3, and from other side or other vertex, it is 2/3 of base. Then this is circle. Circle area is pi r square and its CG is at center. Semicircle. Semicircle of radius r. Then its area is 1/2 of pi r square and its CG is located at a distance of 4r upon 3 pi. Quarter circle. Its area is 1 by 4 pi r square and its CG is also located at a distance of 4r upon 3 pi. Then there are some parabolic spandrel of base B, height h, and equation y is equal to kx square. Its area is bh by 3. C1 from the perpendicular side it is b by 4 and from other side it is 3b by 4. Okay, then this is the another type. Now this is cubic spandrel. That means the equation of this is y is equal to kx to the power 3. Then its area is bh by 4, c1 is b by 5 and c2 is 4b by 5. This is the different type. This is general spandrel. So it is easier to remember this, whose base is b, height is h, equation is y is equal to k into x to the power n. Then its area is bh divided by n plus 1. C1, that is centroidal distance from perpendicular side, is b base divided by n plus 2, and C2, that is distance to the centroid from other vertex, is b into n plus 1 divided by n plus 2. Then the last step will be showing the position of CG, that is center of gravity, on the main figure. So we will see one example on lamina. So the problem statement is like this. The figure is given and the distances are given. So let's solve it and apply the steps we have learnt. So for this figure, step 1 is reference system. So let's decide the reference system. Decide x and y axis. So we took it like this. This is the x-axis, this is the y-axis, and this is our origin. Okay? Now, step 2. We have to divide given figure into basic components. Let's do that. So, we have divided it into 4 basic components. First is this purple triangle, then this yellow triangle, third is the rectangle, and fourth is a semicircle. Now, what is the next step? So, the next step is we have to do the calculations according to this table. So, let's separate out this first figure, that is first triangle. So, can you see this triangle of base 60, height 60, but it is at a distance of 90 from y-axis. So, let's do the calculation. First, find out the area of this triangle. It will be 1/2 into base into height. So 1/2 into 60 into 60. Then this is the CG of this triangle. So what is x coordinate of CG of this triangle? Yes, correct. X coordinate, that means the distance of this CG from this y axis. So it is 60/3. Now y coordinate of this CG, it is this much, 90 plus 60/3. So for this purpose we have taken as a reference system, because we have to find out CG of this complete laminar body. So it is 90 plus 60/3. Now take the product AX and product AY. We have done calculations for figure 1. Let's move to the next figure. So we will separate out this triangle. It is like this. Its area is 1/2 into base into height. So it has 60 and 90 as its sides. So its area is 1/2 of 60 into 90. Now we have to find out x. That is x coordinate of CG of this basic component. But wait, first check if that CG is from 90-degree side or from the opposite vertex. So here it is 2/3 of 60. Now y coordinate, correct. It is 2/3 of 90. Now let's take the product AX and AY. Let's move to the next basic component. Separate out the rectangle. Okay. This is the third geometric shape, rectangle. Show it exactly like in the main figure. It is at a distance of 60 units from the origin. So let's calculate area. Correct. 80 into 90. Then calculate x coordinate of CG of this basic component. What it will be? Correct. It will be 60 plus 80 divided by 2. Now y coordinate of CG of this rectangle? I have shown it here. Correct. It is 90 by 2. Now take the product AX and AY. Now only one basic component is remaining. Let's do calculation for that. First, separate out. So this is the semicircular figure. So what is the area of semicircle? So it is pi by 2 into r square. Here radius is 45 units. So pi by 2 into 45 square. Then what is x coordinate of CG of this semicircle? We already saw the formula for CG of the semicircle. Let's apply that. But wait, don't forget this distance from the origin. So it will be 60 plus 80 plus 4r by 3 pi. Now y coordinate of CG of this semicircle. You are correct. It is r. So it is 45. So come on, let's calculate product of a into x and the product of a into y. Correct. Now we have completed the calculations for all the basic components. So next step is calculating summation of area of all the components. It is this figure. And the next step is calculating summation of the product of A into X. And now calculate the summation of the product of A into Y. Now the final step. Locating the center of gravity of the complete figure. So we have to apply the formula. For lamina, how to calculate the CG? So for x bar is equal to summation of the product of A into x divided by summation of area. And for y bar, it is summation of A into y divided by summation of area. And these are the meanings. So by applying this formula, we got x bar is equal to 92 mm and y bar is equal to 55.5 mm. Now we have to show that into this figure. So this is our given lamina and these are the coordinate axes. So let's locate the center of gravity for this complete lamina. So it is here. So x bar is 92 mm. So the distance of CG of this complete lamina is 92 mm from origin and 55.5 mm on the y-axis. So, after solving today's problem, can you calculate the center of gravity of this mask? Can you? Thank you so much to you all for being with me throughout this video. We will meet in the next video. Happy learning! If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos.